Good day, sir. For this presentation, the GT1-2 is for the bus bar protection, and we were tasked to include a power grid, two buses, three feeders, and the most important part is the differential bus bar protection. The one-line diagram shows a power grid with approximately 285 MVA short circuit, 11 kV connected to the bus 1, followed by the transformer, which is 5 MVA with 11 kilovolts as its primary to 3.5 kilovolts as its secondary. It is then connected to the bus 2. It's 3.5 kilovolts as the same as the secondary of the transformer. This bus then has 3 connected feeders, which are 1.5 MVA, 1 MVA, and another 1 MVA as its load. So since we were tasked to design bus bar protection differential relay, the feeders and the secondary of the transformer has both circuit breakers and relay connected to each of them, and it is connected to the differential relay, which is the number 87. Next is the simulation of the load flow analysis. So for the load flow analysis, shows how design work under normal conditions. As you can see in the simulation, only the bus 2 have warning for error, but all works well. Also, the current are distributed in the feeders, and as you can see, if we add this current in the feeders by KCL, it will be equal to 586, which comes from the secondary of the transformer. The next simulation for the fault. First, I will be putting the fault in the bus bar itself, as being shown on the screen. When a fault occurs at the protected area, the circuit breakers from the load side trip, and in this case, also the CB8 will trip, whereas the circuit breaker for the secondary transformer will trip. But for the ETAP simulations, only 3 are being tripped, but this part of the CB will also trip. The difference in the current measured by the current transformers at the load and the transformer are different. So when there are faults, so the relay acted and tripped the circuit breakers. The next one that I'll be doing is for the simulation of the fault in the load side. In the fault in the first load, which is the 1.5 MVA. When a fault occurred in the load, the same function will be done by the relay, as there are difference in measured current by the both CTs or current transformers in both secondary of the transformer and the load. So in this case, when the fault occurs at the load, CB3, CB4, and CB7 will also be tripped, and afterwards CB8 will also open. In the next case, whereas the fault occurs in the second load, and the same function will happen, as there are only differential relay, and for the differential relay, its function remains the same in every part of the load side. Since it was set to trip CB3, CB4, and CB7, uh, the same function happens. So uh, the order of the tripping of circuit breakers will only change if there are specific relays, such as overcurrent relay connected in the feeders. That time then, the CB nearest of the default will open first. That's all. Thank you.